function is it makes it a little bit easier for me to grade. Okay? So I'm not having to look at 90 people's verifying steps. There are two ways to do this one. I'm going to show you both ways. Okay? You do not have to use all of the answer choices. In fact, you shouldn't be using all of the answer choices. Okay? And this is going to be like one of those multiple response ones where you have to just type in the letter choices. Just type in the letters, no spaces, no commas. Okay? And then it'll automatically grade it for you. Right? So again, like I said, there's two different ways. Line number one, I'm going to go ahead and just start with the left side. It's going to be whatever's on the left side. So tangent squared x, cosine squared x. What letter choice is that? B. So the first thing you do is write B. Okay. So strategy number one is turn everything into sines and cosines. So what's another name for tangent? Notice, did I even look at my choices before I came up with that strategy? Did I even go through here and look at any of that stuff? My idea is that I'm going to try to do the problem, then I'm going to look for the lines. Okay, so which line or which letter does that match? G. Rather than trying to piece it together from what's there, try to go from what you know in your brain and then match it to my step. Okay? All right, what happens from here? Cancel. So my next line should just read sine squared. What letter is that? F. All right. Look where I've got to go. I'm going to use a Pythagorean identity to get there, aren't I? So read me the Pythagorean identity off the pink sign that I can replace sine squared with.
1 minus cosine squared x.
1 minus cosine squared x. Big hint. It was the last thing, right? So the last one, what's the letter for the last one? C. So what you would have typed in is B, G, F, C. Does that make a little bit more sense now that I've explained how to do the problem?
Yeah.
Okay. There's, like I said, there's a second set of answers. Again, I didn't use all of the choices, right? There's a second set that would work. Okay? And I could have gone backwards and gone up. Okay? That would have worked as well. But not mixing up the order. It has to be specific to that order. Okay? All right. So I'm going to start with the same letter again. So again, I'm doing it in a totally different way. All right. Maybe instead of turning it into sines and cosines, I recognize a Pythagorean identity. So what's another name for tangent off the pink sign? Secant squared x minus 1 times cosine squared x. What letter choice is that? Lo and behold, it appears, right? It's letter choice H. All right. What is the instinct telling you to do from here? Distribute. So secant squared x cosine squared x minus secant squared x. What letter choice is that?
D.
It's D. All right. I know I still got to get to this thing here. At the end. Oh, it shouldn't be secant squared. What did I do? Oops. That's not. What am I supposed to put there?
Cosine squared.
Cosine squared x. I apologize. That would have been a problem. All right, I've got this back piece. I don't have the 1 up front, so I got to figure that out. What's another name for secant?
1 over cosine.
1 over cosine. So let's see if that one, 1 over cosine squared x minus cosine squared x. Is that one of our choices?
Yes.
Which one? E, and then what happens next? And the canceling step isn't there, right? But what am I left with now? 1 minus cosine squared, which again is letter C. So you know you got a bookend it with B and C, right? Both times, and then the ones in between that are slightly different. Okay? So listing either one of those in order would have gotten you the credit. Okay? Alright, Adriana, you're up. Angela, you're next. So I can grab which one do you want? 6? Okay, go back to 6. Sorry. 6. Alright. Okay, so on this one we have to verify the identity. Again, when I grade this, I'm grading the steps in between. We have, which side's more complicated, the left or the right?
Oh, wait.
The left has more junk to it, right? Okay, so first thing I'm looking at on the left is I see 2 secant squared. So what are we allowed to do with that? greatest common factor, right? So I'm going to go ahead and pull them out. So secant squared, what's left in the first term? Tangent squared is left, and what's left in the second term? 1. Okay? This looks pretty Pythagorean-ish to me. So look up at that pink sign and tell me what can I replace, or can I replace tangent squared plus 1? Secant squared. And remember, the pink sign, remember you're going to have your sheet in front of you, but the pink sign has them solved all different ways. The sheet in front of you will not. Okay, it'll only have that first column. Alright, so the first secant I dropped down, the second was the replacement. What's secant squared times secant squared? Is that what we wanted? These are the two lines that I would grade on the test. Alright. Alright, Dina, you're next. Angela, which one do you want? 11. Alright, we have to rewrite. This is probably the ickiest problem on the whole test. Okay? It goes a lot of extra lines because there's a lot of algebra simplifying at the end. If you think about how I could change it, the easiest way to change it would be to put 1 in there instead of cosine. Sine, right? So if this is the one on the study guide, the one on the test is possibly sine to the 4. Okay? Whenever we see these words, first power of cosine, that means we are using the power reducing formulas or identities. Okay? So on your chart, you should need to look for that heading, power reducing. Okay? Unfortunately, and this one I think is, remember I changed it in the middle of class and put up a second, so this was the one I changed. Okay, because the other one that was there was even more nightmares than this one. Okay? These ones, unfortunately, are just they always have to use a power reducing twice. Alright, so for power reducing, I know I have to have a squared, so I'm going to convert it to cosine squared x squared. Just taking that fourth power apart. Alright, I need your help. I need you to look up the power reducing for cosine. And you need to make sure when you're practicing, have your chart in front of you. Okay? Alright. So in the denominator, I've got a 2. When I square the 2, what do I get? A 4. And it's probably not a bad idea to go ahead and pull that out front, so I'm not messing with that fraction all the time. Okay? What does squared mean to do with the top part? Write it how many times? Write it twice, so 1. And I'm going to show every tiny little step on this one to make sure you aren't missing anything. I know some of you are going to skip a few steps. Alright. What are we going to do now? We have to FOIL. We don't get to skip any of FOIL because I've got 2 plus signs. If the signs are opposite, we had a plus and a minus, that's where I get to skip the O and the I. Okay? So it's 1 times 1. 1. 1 times cosine 2x. Cosine 2x, and how many of those do we have? 2, right? You've got this, the outer and the inner. This is the one you were asking me about yesterday, right? We were arguing about, or there was something about this. Okay, so this is the one where we double. Okay, we have the signs now. Alright, cosine 2x times cosine 2x is?
Cosine squared 2x.
Cosine squared 2x. Remember, the squared goes on the trig, not on the 2x. Okay? Alright, and you've got to be really careful how you write things, right? We have to make sure we know what's 2x's and what's squared. Go ahead. Because the other one would have had a plus sign and a minus. And that one would drop and allow a minus. Okay. Alright. If all else fails, always cosine 2x plus the cosine 2x combined like this. Okay, that helps you. Alright? Remember, I'm the only one looking at it. Okay? Yeah.
This cosine's 2 squared, would that be the better?
Okay, so that was my next question. Alright? Are we in first power of cosine for all terms? No, we still have a second power of cosine, so that means we get to do power reducing again. This is my least favorite problem. I will let you know right now. But we're still going to put it on there. I know some of us don't really do it, but we've got so many days to practice it. You can practice the problem like 5 or 6 times, right? Yes. I'm so sorry. All right. So let's go power reducing, please. I got it. Okay, so help me out with cosine again. You get 1 what?
Plus cosine 2x.
Cosine 2x over 2. Now, we got to be careful. This part here has to get subbed in, so it's a 2x in there. I know I wrote it squished in. Sorry about that. All right. I'm going to do a little bit of simplifying. 1 plus. So here, from here, it's a lot of basic algebra and fractions simplifying if you've got a mess with. Okay? Because I'm going to show you what it would look like, the answer would look like multiple choice. Okay? If it was just a free response open-ended, hey, you got it, right? But not probably it's going to be multiple choice. So if I split this into 2 fractions, I would have 1/2 plus 1/2 cosine 2 times 2 is 4x. And again, I'm going to show every little step, so it's going to make it long. Okay. I see a 1 and a 1/2. Can't I put those together? Couldn't I turn the 1 into 2 over 2? So what's 2/2 plus 1/2? So 3/2 plus 2 cosine 2x plus 1/2 cosine 4x. Again, another perfectly good answer. But that won't be what it is multiple choice. Okay? So I'm going to show you something that multiple choice test writers love to do to us. Okay? See how we've got these 2's in the denominator? What they're going to do is they're going to factor out a 1/2. So in order to accomplish that, I also need a 1/2 right here, don't I? So I'm going to scale that up, because right now it's 2. I need to write it in halves. So how do I write that 2 in halves? 4 over 2. I have to multiply top and bottom by 2, right? All right. We now see how we've got 2's in all the denominators. I'm going to factor that 2 in the denominator out, which when we factor that out, it looks like a 1/2, which is just going to leave me with the numerator pieces. So I'm going to have 3 plus 4 cosine 2x plus cosine 4x. And notice, all of my powers of cosine are good. They're all first power. So again, all we're doing now is picky algebra manipulation. Okay. All right, the last little thing they're going to do is they're going to multiply 1/4 and 1/2 with 1/4 times 1/2. 1/8. Plus 4. So you see, you're going to see a 1/8 out there, and you're going to go, where did they get this crazy thing from? But this is really a popular thing for multiple choice test writers to do. Again, my biggest thing in AP Calc is they'll get the calculus piece 100% right, and then it's the algebra simplification that they do. So it is something we have to do. All right. That was Keenan's question, right? Or no, was that Angela's question? It was Angela's? Okay. So, I forgot because the question was so long. All right, Dina, you're up, and Maria, you're the next question. So, Dina, which one do you want? 13. 13? All right, go 13. All right. Yeah, you probably didn't have the right answer listed because I gave you the answer to the wrong problem. Okay, I haven't gone in and fixed it yet. So, good one to ask. I'm starting with 3 pi over 2, and we're going to 2 pi according to the domain. So I'm definitely in a triangle in quadrant 3. opposite over adjacent. So my opposite 3, my adjacent 4, which one would be negative? 3, because that's the one that's going down in my triangle, right? And then 3, 4, what for the hypotenuse? 5. Good. All right, the good news is they only want us to find the sine of 2u. I don't have to find the cosine and I don't have to find the tangent. Okay? So, and it specifically even tells you you're going to look under the heading that says double angle. Okay, so that's where you should be looking on your chart. All right, so what is the formula? What number does the formula start with? 2. And then we've got what times what?
Sine times cosine.
Sine times cosine. All right, what is the sine of the triangle?
It's negative.
Okay, and the cosine of the triangle is? All right. My denominator would be 5 times 5, 25. It's my habit that I do my denominator first out of line. All right, and then 2 times negative 3 times 4 is?
23 negative.
Done. Bulk of the work is on the triangle. All right, Maria is up, and Katrina, you're next. Okay. Maria, which one would you like? 14. 14. Okay, this is another one that once you get the formula, not so bad. This formula, the chart that you're going to use on the test is the one that's like the one inside your notes notebook. The formula is squished in between at the very bottom. Okay. You know you're using, because they didn't give you the name of the formula, but by looking at this, you should know that we're using half angle. Okay. And if all else fails, you look for that formatting on the table on the left side of the equation, right? Write down what the right side of the equation is. So cosine of theta over 2. Help me out with the formula. So what do we write down?
Plus or minus the square root of cosine over 2.
In this case, theta over 2, right? Okay, so I only need to find cosine of that triangle. Do I have enough parts of that triangle to find cosine? Of course not, right? That's just too easy. So what's my hypotenuse?
13.
So if you have it memorized, 5, 12, 13, otherwise you use the Pythagorean theorem. Okay? And you can have your calculators out tomorrow. They're not really going to help you much. Other than arithmetic. All right. So now that we've got that, what is the cosine of that specific triangle? Which one is it? 12 over 13 over the 2. So instead of writing a 1, what are we going to write?
13 over 13.
13 over 13. Good. Plus or minus square root of. All right. And this is where I'm going to do a couple things in one step. So 13 plus 12 is what? 25 over 13. And then this thing, what can I do with the denominator? And there's nothing that cancels, right? So I've got square root of 25 over what? 26. This is square root of 25. And from here, yes, we have to rationalize, but if it was multiple choice and you're pressed for time, you could probably look at your multiple choice and pick your answer. We've seen so many rationalized this semester. Square root of 26. So it's 5 plus or minus 5 square root of 26 over 26. All right, that was Maria's, right? Katrina, you get to take it. No, it's a left. Okay. So MJ, you're next, okay? 15 is the one you want? Okay. All right, so it tells us very, very specifically where to go look at our chart, right? So that's what you should do. Look for those words on your chart, okay? So we're doing product to sum. What does the formula operational symbol.
Plus,
And then subtract, and what trig? Sign again, and what operation? Subtraction. Once you got the formula written down, that's the hardest part, right? Just figuring out the formula and write it down. And then I'm going to drop those angle measures in. 3 theta, 2 theta. Alright, what is 3 theta plus 2 theta? 5 theta, and then 3 theta minus 2 theta. That's it. Done. If the multiple choice distributed 1/2, you distribute 1/2. But I think we could all do that. Alright, MJ, you're next. And then Ruben, you're next after that. Which one is 11? We did 11. 8. Okay, go to 8. Alright, so we're going to do 8. We have to solve it. Okay. This is one you're going to want your unit circled out on. Okay. Remember, whatever's in here is whatever we set equal to the radian measure. Okay. Is cosine the x value or the y value?
Yes.
The x value. Okay. So what radian measures is the x value 1/2? Pi over 3, 5 pi over 3, and we're setting 2x equal to that. How do we get the 2 to the other side? Multiply by the reciprocal, divide by 2 and multiply by the reciprocal, multiply by the reciprocal is more useful. So pi over 6 and 5 pi over 6. Alright, Ruben, you're up. Ethan, you're next, okay? Ruben, which one do you want? 16. You need to pick another one then. Find another one you don't know how to do, right? Not a bad thing that he pictures, right? You still get your questions. Alright. Remember, we only have 16 questions on this test, so I only have room to pick like one of each type of question. So you only have one question to prove to me that you understood that identity. Alright? So you've got sum to product. Okay, so we're going to look for that heading on our chart. Okay? What number does sum to product start with? 2. Okay? And then sine plus sine, what's the first piece of trig? Sine. Okay. You okay? You see it on your chart in the right spot? Okay, yeah, you gotta be careful, right? I'm glad you understood your error. Okay? What operation goes first? Plus over 2, and then what's my next piece? Cosine, and then what? Minus over 2. Good. And then what do we do? Drop the angles in, right? There is an extra catch on this particular one. Right? Alright, so we've got sine. What is 4x plus 10x? 14x over 2. And then 4x minus 10x is? Okay. Alright. Then we've got 14 divided by 2 is? Hang on. Get too many buttons. Okay. Alright, so 7x, and then negative 6 divided by 2 is what? Negative 3. Oh, it's going to do it again. It says that it's done. Okay, so negative 3, right? Alright, do we like that negative hanging inside our trig? No, so that's where you got to use the green sign, or on your chart, it's the even, so if you're doing this at home, it's the even odd identities. Okay? And that's right on your paper. got a choice. What do you want to see? Number one. Okay, so we're gonna go back and do number one, everybody. Okay. So on this one, on number one, it says, hey, give me all 6 trig functions. I might not tell you to do that on the test. I might ask for one. Because you know, this is Alex lazy and grading all 6 is a thing. Okay. So we might ask for one, or maybe it'll be multiple choice of some kind if there's 2 or 3 or something. Okay. But if I don't tell you to do all 6, you only practice one, and that's not good. Okay. Let's talk about what quadrant we're in first. So cosine, is it positive or negative? Positive. So which quadrants is cosine positive in? 1 and 4. Okay. Cotangent says it's negative. Out of those 2 quadrants, which one is cotangent negative in? 4. So I'm quadrant 4 answers. Okay. All right. Which two pieces of trig do I get for free?
Tangent and secant.
Tangent and secant, and all I have to do is flip reciprocals. That's like a big thing, right? So, because that's pretty easy. What do I have to do with the secant? Rationalize it. Good. So we've got 2u squared and 2 over 2. So we're just down to square root of 2. Alright, I know I kind of squished tangent in. How do I do the reciprocal? What do I get for reciprocal of negative 1? Alright, so what's missing? Sine and what else? Cosecant. Alright. If you remember from chapter 4 how to do triangles with it, you can do triangles with it. Okay? If you recognize that this one in particular is unit circle values, you can use your unit circle. Okay? I'm going to use the identities that we taught this chapter to do this. Okay? Now, I'm seeing that, hey, cosine is a radical, so I'd rather not mess with cosine, but this number is really, really nice. Okay? And I know my Pythagorean identities match up really well with cotangent and cosecant. So if I look at my Pythagorean identities, I have 1 plus cotangent squared x, actually not in this case, theta, equals cosecant squared theta. You all see that on the big sign? First column, last one. Okay? So that's what I'm going to use to substitute into. What am I going to put in for cotangent? Negative 1 squared equals cosecant squared. It's negative 1 squared. 1, right? 1 plus 1. 2. Alright, how do we undo the square?
Square root.
Square root. What are we supposed to write out front?
That's the point.
If we're in quadrant 4, should it be positive or negative for cosine?
Negative.
Negative. So I'm going to drop the plus and just go negative. So negative square root of 2 cosecant theta. Okay, got cosecant. What do I get for free from cosecant? Sine theta. And we got, I'm going to flip it, right? I'm going to rationalize it and hopefully you recognize that it was just the same as cosine, but with the opposite sign. Okay, so since it's 11, I said originally they're going to be 3 for the class, it gives you 4 for the class. Okay, so anybody in class can call out which one they want. Now is your opportunity. You didn't get to pick one. Which one? 5? You don't even have to read it. Alright, so number 5. We got to verify it. So which side is more complicated, the left or the right? The left. Okay. I'm going to say, hey, let's go to sines and cosines. So what's another name for secant? Well, I know we're cosine, and if I really wanted to, I don't have to do this line. Couldn't I put sine over cosine? What's sine over cosine? Really, you could get away with just that line, but if you had both, that's what I would grade on the verifying. Remember the first line and the last line, I really have to grade. All right, you got 3 left. What other 3 do you want to see? Give me one.
10.
10. Oh, yeah, 10 is 10 is super easy. It's meant to be super easy. Okay. So again, you're having to the first thing they did was they took their tangent and turned it into sine over cosine. Why was that really good? What does it do?
Cancel the cosine is multiplied by that.
It cancels the cosine, so you need to write the line without the cosine in it. So cosine squared x plus sine squared x. That's all I'm looking for the answer. But you can check it with the next line to make sure you did it right. So what's cosine squared plus sine squared according to Pythagorean identity?
1.
1. Okay? So that one, you really, it's trying to be a gift for you, right? So you recognize what happened with the trig, and you have to just write the next simplified line. Okay? Alright, you got 2 more. What else? 7? Okay, so let's look at 7. Alright. So we've got to solve for x. What am I going to do to move the 2? Add it. Good. So secant of x equals 2. The secant on our unit circle. No. Okay. So what can help us on our unit circle that's related to secant? Okay, cosine. What do we know is their relationship? How do I get from secant to cosine? Flip, it's called reciprocal, right? So we know we're looking for the cosine of 1/2. Alright, is cosine the x value or the y value? X. So where is the x value equal to 1/2? Alright, you've got one left. We want to see for our last one. Which one? 4? Yeah. Okay, 4 is going to be our last one. Fundamental identities are just the identities. They'll sometimes say fundamental. Okay. It's probably more likely to be like our Pythagoreans and our reciprocals, but it doesn't have to be. Okay. So this is looking really Pythagorean to me. Okay. So let's look up at the Pythagoreans. What can I substitute in for cosecant squared minus 1? Good. Really good at that substitution. Now, I bet I could probably get it simpler, right? So, one more time, Shanice? Good. We're going to go to sines and cosines, right? When all else fails, that's what we do, right? Okay, so we're going to go to cosine, cosine. Cosine squared over sine squared. Okay, what happens now? Sines cancel. My final answer is
Cosine squared x.
cosine squared x. I lost my x.